All right, let's just dive right in. You've seen them, right? Those mind-bending headlines about reality that pop up in your feed all the time. They're super exciting, they're dramatic, but are they actually true? Today, we're going to build a toolkit to help you tell the real science from this sensationalist nonsense. Like this one. We live in a simulation. I mean, you've probably seen this, right? It's everywhere. The idea that our entire existence is just some super advanced computer program. It's a fascinating thought, for sure. But is it science? Or what about this one? The idea that the 3D world we see and touch is really just a projection coming from a flat 2D surface. I mean, wow, right? It sounds like something pulled straight from a movie. And then you get claims like this, the kind that seems to just break the fundamental rules of the universe as we know them. This is the kind of headline that gets your heart racing, promising a future we've only ever dreamed of. So this is the big question, isn't it? When we see these incredible claims, how are you supposed to sort the groundbreaking discoveries from what's basically just profitable clickbait? That is exactly what we are going to break down right now.
To really get where these headlines come from, we first have to understand that there's this massive gap at the very heart of modern physics. And it's this gap that creates the perfect breeding ground for all this sensationalism.
Yeah, the problem kicks off right here. Believe it or not, our two absolute best, most successful theories for explaining how the universe works fundamentally contradict each other. So check this out. On one hand, you have Einstein's general relativity. It perfectly explains the grand cosmic dance of planets, stars, and galaxies, the big stuff. On the other hand, you have quantum mechanics, the super weird but brilliantly accurate theory that runs the tiny world of atoms and particles. Both of them work flawlessly in their own domains, but they just do not play well together. And because these two giants of physics are at odds, it creates a kind of vacuum. Science doesn't have all the answers yet. So when some wild idea comes along, scientists can't always just say, nope, that's impossible. And that uncertainty, well, that's where sensationalism loves to live. It's where speculation gets to dress up and pretend to be fact.
This brings us to a really key concept, the absence of a complete machinery for reality. All that means is we don't have a single unified rule book that explains everything, from the smallest particle to the biggest galaxy. If we had that, spotting nonsense would be a piece of cake. But we don't, and that's why we have to be our own detectives.
Okay, so we've got this gap in our knowledge, but how does that turn into those crazy headlines we see? Well, the good news is they tend to fall into a couple of pretty recognizable patterns. Once you learn to spot them, you're already halfway there. First up, we have what I call the what is reality claims. These are the ones that take a cool philosophical thought experiment, or maybe some really speculative math, and present it as if it's a proven scientific fact about our existence. And you have definitely seen these before. We live in a simulation. We live inside a black hole. The universe is a giant computer code. Look, these are fascinating ideas to think about, no doubt, but they currently lack the hard evidence and that machinery to be considered actual science. Now, the second category is even more dramatic. These are the breaking the rules claims. These are the headlines that shout that we've totally overturned a foundational, time-tested law of physics, like the universe's ultimate speed limit, the speed of light. And whenever you come across one of these, there's a vital tool you have to use. It's called the Sagan standard. It's named for the great astronomer Carl Sagan, and it is a fundamental principle of thinking critically about the world. It's this simple but powerful idea. Extraordinary claims require extraordinary evidence. That means if someone claims they can travel faster than light, they can't just show you some fuzzy math on a whiteboard. No way. They need overwhelming, undeniable, revolutionary proof. The burden of proof is on them, and it is huge. So claims about faster-than-light travel or using wormholes to hold space-time together absolutely fall into this category. They are extraordinary claims, and because of that, they demanded extraordinary evidence before we should even begin to take them seriously. Okay, so we've identified the problem, and we've spotted the patterns. Now for the practical part. Let's build your personal toolkit. Here are 4 simple questions you can ask to vet any science headline that crosses your screen. 1. Is there a plausible machinery? Does the article actually explain how or why this thing would work? 2. If it's a huge claim, does it have huge evidence to back it up? Does it pass the Sagan standard? 3. Is the headline just a misleading question? Like, could we live in a simulation? That's often a big red flag for clickbait. And 4. Who is telling you this? This last point is so important. You gotta vet the source. A peer-reviewed scientific paper is a great start, but you still need to be cautious. A university press release? Be very cautious. They're often designed to grab attention. And a pop science blog or media outlet? Okay, that's when your caution level needs to be on extreme. Their business is often clicks, not necessarily scientific accuracy. So after all this, what's the real takeaway? The goal here isn't to become a cynic who just dismisses every new idea out there. Far from it. The real mission is to learn how to approach the universe with both wonder and wisdom. We should absolutely keep asking the biggest, wildest questions we can think of. But we also have to learn to appreciate and celebrate the rigor, the hard work, and the evidence-based process of genuine scientific discovery. Because that's where the real magic happens, not in some flashy, empty headline. Ultimately, it's about learning to tune out the noise so we can hear the actual music. By using this toolkit, by demanding evidence, and by separating speculation from science, we can become better listeners, ready to hear the incredible, authentic story the universe is waiting to tell us. And trust me, that story is way more amazing than any clickbait headline. Thanks for joining me.